In this lesson, we're going to talk about how to multiply polynomials. We're going to talk about terms versus factors. We're going to look again at the distributive property, and then we're going to look at how to multiply the polynomials. So first, let's talk about terms versus factors. So in 4x squared minus 3x plus 2, 4x, negative 3x, and 2 are terms. 4x, negative 3x, 2 are terms. And they're not like terms because they don't have the same form of the variable, but they are terms. There are 3 terms here. 4 and x are each factors of 4x squared. 4x squared means 4 times x times x. Those are things that are multiplied together. Those are factors. Negative 3 and x are each factors of negative 3x because that's negative 3 times x. Each one of those is factors. Terms are numbers that are added or subtracted, and factors are numbers that are multiplied. Let's take a look at this expression. We have the quantity 4x plus 3 times 2x plus 1. You see here between the 2 parentheses, they're touching, so that's multiplication. 4x plus 3 is a factor because it's multiplied times 2x plus 1. 4x by itself is a term, and 3 is a term because they're added together. But then when you consider 4x plus 3 all together, it's a factor. Why is this important? With terms, you can only add and subtract terms if they are like terms. So if I want to add 4x plus 2x, I can do that. If I want to add 4x plus 1, I can't do that. But I can do this. With factors, I can take 4x times 2, even though they're not the same, and make it 8x. Or I could take 4x times 3x squared and make it 12x to the third power. It's also important that you consider these as factors, as one whole factor that is being multiplied. All right. Now let's do an example. So I'm going to multiply 2x times 3x minus 1. So 2 is a factor, x is a factor. These are terms, 3x and minus 1, but the whole thing together is a factor. So I can multiply 2x times this whole thing. Now I have the algebra tiles here to model it real quick. So I'm going to put 3x minus 1. Of course it'd be minus 1, so it's negative. It's a pink guy. Get a little more space here. And then I have 2x here. So x times x is x squared. And everywhere I have that, I'm going to put another x squared. And down here. And then I have x times negative 1 is going to go here. Well, that would be a negative x. X times negative 1 would be negative x. So the answer to 2x times 3x minus 1 would be 1, 2, 3, 4, 5, 6x squared. Notice I have 6x squareds. They're not x to the 4ths or x to the 8ths or anything like that. 6x squared. And then I have 2 negative x's, so minus 2x. So that's one way to look at it. The other way is the distributive property. So we can distribute and multiply times each term in the, so basically instead of taking x, each x of the 2x times each separate piece of the 3x, I can just do it all together. So I can do 2x times 3x. Let me write it out. And then 2x times 1. 2x times 3x is 6x to the second power, because that's what x times x means, is I have 2 x's multiplied together. Let's see, I got the same thing here. Minus 2x times 1 is 2x. Let's look at another one. We're going to multiply 2x plus 3 times the quantity 3x minus 1. I'm going to put 2x plus 3 up here and 3x minus 1 here. Ta-da! 3x minus 1, 2x plus 3. Now I'm going to start filling these in. And so that is 1, 2, 3, 4, 5, 6 x squared. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 x, and we have 1, 2, x, and then we have minus 3. So these were factors that I was multiplying factors together, and I could multiply x times x or constant times x, it doesn't matter because I'm multiplying. Now I'm back to adding. These are all terms. So I can combine anything that's like terms here. So I can combine these two together because they are like terms. And using my zero pair property, oops, I was trying to get the arrow there. These two together make a zero pair, and these two together make a zero pair. And we're left with 1, 2, 3, 4, 5, 6, 7 positive ones. Now, maybe you don't have algebra tiles or you don't want to take the time to work that all out. We can use the distributive property. It's just the distributive property times a bazillion. So we're going to take 2x times that whole parentheses, each term times the whole parentheses. And then we're going to do plus 3 times 3x minus 1. And I would really encourage you to write it down like this. This is the same thing I did over here, just without the algebra tiles. So instead of taking 2x, each individual x times each individual x of the 3x, I'm just going to multiply them all together right now. So 2x times 3x is 6x squared. 2x times the negative 1 is negative 2x. And then I do 3 times 3x is 9x. And then 3 times minus 1 is minus 3. So minus 3 here. Here's the 9x that I had. Here's the minus 2x. They've disappeared because I'm going to cancel them out again. I'm still getting the same factors, different way. So that's this is called the distributive property way of doing it. And then we have the algebra tiles way of doing it. And then there's also the box method, which I'm going to briefly show you right here. We have 2x and 3, and we have 3x and minus 1. It's the same process, just a different representation. So we're still taking 2x times 3x. It's still 2x times 3x is 6x squared. We have 3x times 3 is 9x. We have 2x times minus 1 is negative 2x, and minus 1 times 3. All of these are all the idea that we're taking each term in one factor times each term in the other factor. And then we can combine these two together again and get whichever one makes the most sense to you, whichever one feels the most comfortable to you, use that method. All right, one more example. Multiply 2x plus 3 times the quantity x to the second power minus 3x minus 1. I could put the models here, but when you multiply a square times one of the bars, you get a cube, which would actually, on the algebra tiles, it would actually look like a cube. And we could do that, but I want to show you without the algebra tiles. So we would put, kind of like the box method, just put one polynomial up on the top. This is a trinomial. And then put the other trinomial down here. And if you want, you can even draw some lines to help you with the spacing. And then you multiply 2x times x. So there are 2 x's here multiplied together. So altogether there are 3 x's multiplied together. Remember, we're multiplying in this step. So 2x times negative 3x, right? That would be negative 6x to the second power, because x times x is x to the second power. And then 2x times minus 1 is minus 2x. And then we do 3 times each one of these. So 3 times x squared is 3x squared. 3 times negative 3x is negative 9x. And 3 times minus 1 is minus 3. And then usually along the diagonals are the ones that you can combine. So we can combine these guys together. And we can combine these guys together. And then we take a moment to look at this beautiful artwork that we have created. Just think, you wouldn't have understood this 6 weeks ago, 6 months ago.
And now hopefully you do. So we have negative 2x, or we have positive 2x to the third, negative 6x squared plus 3x squared minus 9x minus 2x minus 3. And those ones that are on the diagonal, now we're adding. So up here we were multiplying because these were touching. Now we're adding. So we can combine these like terms together. And remember, picture 6 red squares and then 3 red squares. 3 of them would cancel out. These 3 red would cancel out with these 3 green, and you'd have 3 red left. So your answer would be 2x to the third power minus 3x squared minus 11x. So this would be 9 red bars, and 2 more red bars would be 11 red bars minus 3. Notice when we multiply, the exponents are changing. X times x is x to the second, and when we add, the exponents are not changing because you're just getting more squares. I'd also like to, I know this video is getting kind of long, but I really want to show distributive property real quick because I know some of you will like that. The distributive property says we take 2x times this, so 2x times x squared minus 3x minus 1, and then we're going to do 3 times each one of those. So that would be plus 3 because it's a plus 3 right here, times x squared minus 3x minus 1. I'm going to do this real fast because the operations are exactly the same. And if you're good, you can go ahead and line up those like terms as you multiply them. Oops. Minus 3. Don't forget to distribute the 3 to everybody. And then 2x to the third. I messed something up, didn't I? I was trying to do it too fast and talking at the same time. I was like, I'm not getting the same answer. 2 times 3 is 6. Some of you were already screaming that at the screen. I hear you. I hear you. Same answer. Same method, really, just a different way of organizing it. Hopefully now you have a little bit of understanding of how to multiply polynomials. Now go practice.